Thank you, everyone, for taking your time to attend uh, the event, and that too on a weekend. I appreciate it. And I'm going to talk about how to control devices using Power App with the help of Raspberry Pi. And I'm a Microsoft certified trainer and also a solution architect working for Tata Consultancy Services. And these are my social handles. If you want to connect with me, please do connect. And if you've got any questions related to what I'm going to present today, you're most welcome to connect with me on these channels and any of these channels. I also blog about Microsoft 365 and also a Power Platform with Azure, etc. On this website. I appreciate you to take a look at it. And also, I run an cloud journey meetup group, and we have it is an initiative which has been started a few months back, and there are around 100 plus participants as of now. And we do talk about the experiences, the cloud experiences, especially when coming to Microsoft and Azure services. And I would like to also thank you very much for the sponsors, Hubfly, Kowai.co, and Quadra. So I'll go to the agenda now. So this is what we are going to uh, look at it on this session. So as I said, I have used Raspberry Pi to control devices from anywhere in the world. Right, so you can easily do it with the help of PowerApps, which is an SAS solution. Right, so it is not that complex to build this up. I hardly took a few days of effort to complete this assignment. And I will talk about what is Raspberry Pi, right? And also next is the prerequisite. So what all I have used to achieve this, uh, and then when coming to controlling your devices, so what are the different components I have used? Because if you have to control the devices, you also need a cloud service like Azure IoT, right, which helps us in achieving that. And moreover, if you have to control it from your Power App, and we'll have to write a custom connector, right? So I'll be showing all those components, and then followed with a quick demo. Uh, and then at the last, I will take up questions if there is any. Yeah. So our first slide. So what is Raspberry Pi? So most of you would have heard of this. It is a very powerful computer. It is a credit card sized device which has got all most of the capability which our laptop or desktop has got, but it is much cheaper. You can do a lot of programming languages. For example, you can write Python programs, Scratch, and also .NET Core. Right, for the whole for this project, I've used .NET Core because I'm more comfortable with .NET than compared with the other languages. Right, and also you can make an RDP connection. If you're using Windows 10, you can use the Microsoft terminal services to make an RDP, which means that you can remotely connect to the Raspberry Pi from your Windows client with the help of the terminal services. All right, and this is actually the schematic of the Raspberry Pi, and you can see here it has got USB ports, and it has got an Ethernet port. It has got also a Wi-Fi adapter. I have I'm using an Raspberry Pi 4, which has got 4 GB RAM, and there is also another version which has got 8 GB, and the price is almost is almost 6,000 bucks, I 6,000 INR, right? And these are the processors which it has got a powerful processor as well. Right, and this one here, the micro SD card slot, and this is where the operating system runs. So you'll have to load the operating system onto a SD card, and then you can put that on the you can connect to this Raspberry Pi, which will then boot that operating system once you power on the device. Right, and so it requires a five volt a power, micro USB power. It has also got an HDMI port, and if you have got a monitor which you would like to plug into the Raspberry Pi, you can do so. But I haven't used that. I'm remotely connected to the Raspberry Pi using the same computer where I currently work. And you can also have a camera hooked up to the device, to the Raspberry Pi. It has got an audio jack. Yeah, it is almost similar to what we have got on our laptop or desktop. Right. So this part is actually the powerful feature, which I do like it very much. And if you wanted to do your IoT projects, and this is where we go. And this hardware feature, it is called as GPIO pins, and Raspberry Pi 4 has got 40 pins, right? So this is the pin diagram. For example, pin number 1, you will get 3 volt out of it, and pin number 2, 5 volt, and there is one more 5 volt power source, right? And these are the other pins. So for example, on this demo, I have used 2 pins to control an electrical device, be it light, etc. Right, but on this demo, I have used an simple LED, which we are going to control it from the Power App. So I have used pin number 17 and pin number 18. Right. So when it comes to the pin, and there are actually 2 modes for the pin. It can be either an input, which helps us to work with sensors. For example, if you have to measure the temperature, to measure the humidity, or measure the pressure, etc., you'll have to use the input mode. Right, but for us, for this session, I have used the output mode, because we'll have to control the devices. So let's say I wanted to turn on the light. I'll be using this pin number 17. I'll be sending a message or sending an event from the Azure IoT, which will be then sent, which will be then reached to the Raspberry Pi on this particular pin. So it's pin number 17 or 18. Right. So when it comes to the operating system, you can have there are a lot of operating systems which can be run on a Raspberry Pi. So on this for this event or session, or for my project, I've used Raspbian. Can also run Ubuntu Core on it, and there is also an operating system version for Microsoft. It is called as Windows 10 IoT Core, and all of these are open source. My Microsoft has even open sourced Windows 10 IoT Core, right? But I don't see more development from Microsoft or for Raspberry Pi, and Windows 10 IoT Core works only with the previous version of Raspberry Pi, 3 Raspberry Pi 3 or so. It works with that, but not with 4. Right. So I have used Raspbian here. So yeah. So this is the prerequisite. Uh, this is what I have got to do this project. I've got a Raspberry Pi 4, as I've already said, and also you require an internet connection, right? So that whenever you're sending a instruction for a device to be controlled, to be turned on or off, you require an internet connection for the Raspberry Pi. So my Raspberry Pi is connected through Wi-Fi. And also, if you know the IP address of your Raspberry Pi, so whenever you're connecting your Raspberry Pi to your internet modem, be it through an Ethernet cable or through Wi-Fi adapter, there'll be an IP address assigned by your router to the Raspberry Pi device, and we need that actually to remotely connect or remotely code your Raspberry Pi. Because I have used Visual Studio Code, there is a plugin which is available for remote development. I require this IP address or the host name, right, in order to remotely connect and do coding with your Raspberry Pi. So this is required, and there are actually ways to get that information, to get that IP address. One is, once your Raspberry Pi is connected uh, to your Wi-Fi router, then you log into your Wi-Fi router page and get the IP address. So that is one way. And the other way is there are actually sudo commands, Linux based sudo commands, which you can use to get the IP address, right? And I have also used a breadboard and also an GPIO extension cable, so that I can link the Raspberry Pi and the breadboard to further do some connections with all these LEDs, resistors, etc. Right. So this one, I have also used a couple of resistors and LEDs and also an relay module. So why relay module? And if you have to turn on a high-powered device, right? For example, a fan, or for example, a light which works on an AC power, you require a relay module, right? I'll be quickly showing that as well. So when coming to the Raspberry Pi, as I already said, I've got a Raspbian OS on it. I've got .NET Core 3.1 installed on it, right? And we know that we also have .NET 5, which was recently released, but that will also work. But I haven't tested yet, right? And the other important configuration is SSH, which needs to be enabled if you have to do remote development, right? And next one is you require root permissions. If you Because the GPIO pins, which we are going to be using to control the pins, right? To do that, you require root permissions. And coming to the Visual Studio Code part, we have installed a remote development plugin, which is again free, open source. You can use this plugin to remotely code with your Raspberry Pi. And also, I've used a Nugget packet manager, which helps you to add Nugget packages. And we have I have used two Nugget packages in order to control the GPIO pins, and also one Nugget package is for the Azure IoT client. And next one is console application, which will be running. I'll be discussing on about this later down the line. So this is the design, right? So these are the different components which I have got. So we have this Power App, and whenever you're turning on the light or turning off, it sends a message to the Raspberry Pi console application, which will be running on it, a .NET Core console application, and it sends through a custom connector, uh, right? And it sends a message to the IoT hub, which wherein on the IoT hub I've got a device registered, right? So the Raspberry Pi has been registered on this IoT hub, and I'm then sending a message through a Azure function. And if you have to call a Azure function on your Power App, you need a custom connector. Right, so this is the on a very high level the design looks like. And the .NET Core console application, which is running on the Raspberry Pi, I'm connected to it with the help of SSH, remote development. I'll be showing that quickly during the demo. Right, so okay, coming to the components. So as I already said, we I have used two packages. One is system.device.gpio. And if you have to control the GPIO on your Raspberry Pi, you have to have this package. Right. There are also Python packages. If you're good at Python, you can use a Python package, which is also available to control the GPIO pins. And since I'm using Azure IoT, right, so I also need this particular package, Microsoft.azure.devices.client. Right, so this is the console application where I've got two packages. I will also give a quick code walkthrough on of the console application. So next one is IoT Hub. Right, so I have got an IoT Hub instance on the Azure portal, which has got a device registered. And there is also a free service or free tier for IoT Hub, which you can try. And you can send up to 8,000 messages, which the free tier, right? So this particular IoT Hub, I've got only one device registered, which is the Raspberry Pi. Right. So the next one is an utility which is as of now in preview mode. Right. So you can completely access the IoT Hub devices. You can send the message, etc. With the help of this small utility from Microsoft. I'll be also showing that, and we have got a function, right? And I will quickly show on the demo. You will be understanding on how I made all this connection, right? So we have an Azure function with this package Microsoft.azure.devices, which sends a message to the IoT Hub. Then the IoT Hub sends the message to the .NET Core console application, and this one as an is an HTTP trigger Azure function. So whenever you're making a GET request to the function, it sends a message to the IoT Hub, and then it then controls the GPIO pin. And the authorization which level which I've used for this project is function. It's not anonymous. And then we have got a custom connector. So you know that Power App has got a lot of free connectors. Right, standard connectors, like if you have to connect to SharePoint, you can easily connect. You can easily connect, make create an item, delete an item, update an item, etc. Right, and there are a lot of other connectors like lot of connectors, right? And if I have to call a Azure function, which is my own API, and if you have to call that from the Power App, I have to have a custom connector, right? And it is also good to know that if you're using a custom connector, you should have a premium license, right? And if you're using standard enterprise license like E3 or E5, you'll not be able to create a custom connector. You need a premium license to create a custom connector, and also all the users who are going to consume this app should have a premium license. Right. So next one is the Power App. Right. So I've got few UI controls like toggle buttons to to turn on the light or turn off the light, and also I'll be calling the custom connector from this Power App. Right, so let me now switch to the demo. Okay, so I said we can make a terminal connection. Uh, right? I can remotely connect to the Raspberry Pi. So this is the Raspberry Pi operating system. I've made an MSTSC TA term RDP, right, to this Raspberry Pi through with the help of the IP address, right? And I said to remotely connect or to code against the Raspberry Pi, there is a configuration which you'll have to have it. Uh, that is SSH that needs to be enabled, right? So this one, so this S and by default this is turned off. SSH by default it is disabled, and you will have to enable this if you have to remotely connect through the Visual Studio Code, right? So that this the first configuration you'll have to make it. And now I will quickly do a code tour of the console application. Okay, so this is the console application. This is actually running on the Raspberry Pi, uh, right? And I will also quickly show the plugins, right? So extensions, so Remote Explorer. Uh, so Remote Explorer is installed, right? Remote SSH binding. I have also written a blog post which will help you to find that plugin. But I'm now remotely connected. You can see here I am remotely connected to Raspberry Pi, which has got this IP address. It is a private IP address 192.168.0.141. And to do this initial configuration, first of all, you'll have to uh, make an host available. Right, so you'll have to first of all add an SSH. It is a one-time configuration. I've already made it. Since I know the IP address assigned to the Raspberry Pi from the router, I've created already this host SSH configuration. I'm now remotely connected, right? I'm already connected to this to the IP address, right? I'm now. You can also start the terminal, right? And this code is actually in the Raspberry Pi. I'll also quickly show that where I'm referring to. So this one is the code home pi, right? So this particular code, console application code, I'm accessing it from my a client Windows 10 computer, right? So now I'll quickly do a code walkthrough. First step is you will have to add the package system.device.gpio and also the other package microsoft.azure.devices.client, and this one actually helps to send messages to the IoT hub, and this is the first step which you'll have to be doing. And the next one is once you should also register the device on the IoT hub, and once you have the device registered, and you will get the URI and also the device key, right, and also the device ID. I will quickly show that as well. And also, as I said, I have used GPIO pin number 17 and 18 to control the devices. And next one is you'll have to create an cancellation token source. And if you're terminating the console application, you'll have to have this instant initiated on your console application, right? And next one is you'll have to create an instance. You'll have to open the pins. So in this case, we'll have to open the pin number 17 and 18, right? You'll have to first of all initiate an a, fun you'll have to create an instance for this GPIO controller, which is from the package system dot devices dot GPIO. You'll have to do it, and also create an instance for the device client so that you can make a connection to the IoT hub. Right. So next one is uh, wh- till there is an cancellation or termination request on the console application keeps running. That is why we have got this while loop. And next one is the uh, okay code to read the message, and you will understand it once I show how sending message from the IoT hub. And after we send the message, and it has to the console application has to read. For example, on this project, I've got two devices to be controlled, right? And on pin number 17 and 18. So if I have to turn on the or call the 17 pin number 17, turn on or turn off, right? I send a message, and to read it, this is the code. Right, so we'll have to read the message what we are sending from the IoT hub. And next one is yeah, reading the message. And next one is the case statement. So based on if you have to turn on the device number one, right? I'm just using on one, which turns on the first light, and if it is off one, it will turn off the light number one. Right. So what it means is on the pin, on the GPIO pin for 17, be it any GPIO pin, the output or input pin 17 or 18 here. So whenever I make it high, pin value dot high, it will create an you'll have 3.3 volt on that particular pin. And if you set it to low, right, and it will be zero, and there'll be no voltage or no power on the particular pin. So this is what we are doing, right? So when there is a message on number one, the pin value will be set to high, and which means that on that particular pin I'll be having 3.3 volt. And if the message is off number one, and the value will be set to zero, and there'll be no power or no voltage on the particular pin. And to do the same for the next pin, pin number 18, right? And it has to be on too, and to off it has to be off too. Right. So the last one is yeah. So once you receive the message from the IoT hub, you'll have to call this device client dot complete async. What it does is it deletes the message from the IoT hub queue. So that is it. So let's now quickly start the .NET Core application. .NET run. Yeah. So now the program is running on the Raspberry Pi. It is waiting for the messages from the IoT hub. Right. So this is the Explorer, which I have shown on the components slide, Azure IoT Explorer. And with the help of this utility, you can send a message to your device. Right. So let me quickly show the device which I've registered. I've got this Raspberry Pi device registered. Right. So I'm clicking on it. And now let's try sending a message to the Raspberry Pi. I'll also quickly now turn on the camera to show the connection at the Raspberry Pi and also the breadboard. Yeah, so you can see here. This is the Raspberry Pi. and here is where the GPIO pins are. The GPIO pins are extended with the help of this GPIO extension cable, and this is where you also see the same pins in here, right? I've got two lights. One is directly connected to the GPIO 17, and the next light, light number 2, is is connected through a relay, right? And you need this device, and if you have to control a high powered device, right? For example, an AC alternating current device, a light, right? A powerful light, or a fan, right? You need this device which actually decouples this Raspberry Pi and the other and the other high powered device. So you make these connections here. I think because I'm from an electrical and a background, I did my engineering on this. I've used already these kind of devices during my engineering project, but it is not that complex for you to understand, right? So the second light, I'm turning it on through the relay, right? So let's now quickly send a message. I'm using this cloud to device messaging. I'm sending a message on 1, right? You can see the light number 1 is turned on, right? Let's now turn on the second light on 2, right? There is also a click sound happened on the relay because right, the 3.3 volt which is generated from this pin number 18, it actually triggers this relay, which is then turning on the light number 2. Let's now off the light, off light number 2. I'm sending the message to device. Light number 2 is turned off. Right. I will also now turn off the light number 1. Yeah, light number 1 is also turned off. Okay. So let me now show the Azure function, because I'm right now I've used the utility, right, the IoT Explorer to send the message, right? And if you have to send these kind of messages from the Power App, you need an Azure function. So let me quickly show the code of the Azure function, right? So it is a simple HTTP request, right? So uh, the connection string for your Azure device. So this is that, and the device name, and we are making an get request, right? So there is an SDK to for sending the message to the IoT hub. Right, I've shown you the device explorer, so now we'll have to do that programmatically, right? So this is that Microsoft this is that namespace which we'll have to import it to your Azure function first, and this is the method which sends the message, right? So we are sending the message, whatever we get as a parameter from the Azure function,